All right, welcome to lesson 24. This is the second part of absolute and relative change, and we're starting on page 215. You'll notice we're starting here with the CPI, the Consumer Price Index, and we've played with this before. If you remember back from Unit 1, we used the CPI table to estimate values of goods at different times. Well, now we're going to use this to talk about inflation, which is relative change. So we can compare year to year overall, or we can talk about in terms of months. So we are going to start with that in terms of the inflation rate for April of 2014. Well, if we're doing it that way, then April of 2014 would be considered our new value, and exactly 1 year prior, which is April of 2013, would be considered our old value. So when you look at your table, April 2014, there's our new, 2013 is our old. So when I'm looking at this, I would take my new minus old divided by old. And we are finding our relative change because remember the inflation rate is another way to talk about relative change. So when you subtract a numerator, and remember you want to subtract, hit equals, right? Get a number for your numerator before dividing by 232. You should come up with 0.0195 or a 1.95% inflation rate. So notice again, because that's positive, from 2013 to 2014 in April, our inflation rate has increased because of that positive answer. So now on number 2, how much would you have expected to pay for goods in April of 2014 if those goods were worth $1,500 in April of 2013? Well, we know that there was an increase of 1.95%. So if I take the value of the goods in April of 2013 and multiply by my increase, that means my amount of increase was $29.25. Right? So that's the amount of increase. So how much did they cost total? Well, the $1,500 plus the amount of increase. So my new price for these goods would be $1,529.25. And so it's a little bit different than the way we found that information in Unit 1, and both ways are correct. Mathematically, they're very solid. Just wanted to kind of show you a different way of figuring using the CPI table. All right, we're going to move on to this little box here in the middle of page 215, and we're going to find the inflation rates for all the years listed in the table. And we're going to round to 4 decimal places. Now, we're going to do 2009 here together, and then I'm going to cut you loose and have you guys work on the rest of them. So 2009. Now, if we think about that, that means this is new. And to find the old, I will have to use 2008. So if we go back to our table, now we are going to use the annuals because we want overall years. So 2009 and 2008 are the two values that we're going to use. So 2009 has a value of 214,537, and 2008 is 215,303. So when I use that, of course I didn't leave myself any room, 214,537 minus 215,303, and I'm going to divide all of that by the old, which is 215,303. And again, I got to make sure I have my numerator taken care of before I divide. And you can see very clearly that in the numerator, you're going to have a negative value because 214 minus 215 is going to give you negative. So I am going to have a negative for 2009. And to 4 decimal places, I've got 0.0036. Now, as a percentage, right, we'd move it 2 to the right and get negative 0.36%. But for this particular case, we are going to just leave it in terms of decimals. So just to kind of refresh, so for 2010, this would be considered new, and then 2009 would be considered old. So every time you move up a year, the previous year is going to be considered old. So I want you to hit pause and find the inflation rates to 4 decimal places for the rest of this table. Okay, so I have completed it. Notice that the 2009 is the only inflation rate that is negative. Every other year has a positive inflation rate, meaning the prices have gone up. So if you have questions on how I got those, the numbers that I used, shoot me an email. I can give you more details that way. Moving on to number 4. Let's interpret the inflation rate for 2013. So the inflation rate for 2013 is 0.0146. And I'm going to go ahead and change that to a percent because I think it makes most sense to talk about it in terms of that. And I'm going to go ahead and type up. So the Consumer Price Index increased by 1.46% from 2012 to 2013. When you're writing these meaningful sentences, you need a time period. You need whether it's increased or decreased, and by how much, the actual value, and then what are you talking about? So your meaningful sentences with these should have 4 pieces: time period, increase or decrease, value of increase or decrease, and the topic of what you're talking about. So if you have all 4 of those, you're probably doing okay. And what does the negative inflation for 2009 mean? Well, remember, if it's negative, that means we had a decrease. So we had a decrease from 08 to 09 because of that. Remember, 09 uses 08 as our old reference time. So because of that, we had a decrease from 08 to 09. All right, let's move on to page 216, page 216. Now, we are going to use this statement. It's in a box on page 216, and it's the teen abortion rate declined 66% between its 1988 peak and 2010, from 43.5 abortions per 1,000 to 14.7 per 1,000. So the first thing is, what percent of teen pregnancies ended in abortion in 1988? Well, there's a couple different ways you can think about it. And in my class, we do a lot of proportion work. So when I see what percent, that makes me think X over 100. And on the other side, right, part to whole, in 1988, we had 43.5 over 1,000. Hopefully you remember solving proportions, cross multiply, so 1,000x equals 4,350. And we divide both sides by 1,000, and we end up with 4.35%. So 4.35% of teen abortion, of teen pregnancies resulted in abortions, in 1988. Now in 2010 we do the same thing. So what percent? That one we had 14.7 over 1,000. Again, cross multiply, and we end up with 1.47%. Now there are other ways to do this. I get it, but I try to stay consistent in the way I teach things. So since we've been working with proportions so much, I've just been staying with it. And number 3, the absolute change in percent of teen pregnancies. Well, 2010 is going to be considered new, and remember we had 1.47 percentage points in 2010. And then in 1988, which would be considered old, we were at 4.35 percentage points. So new minus old, I would take 1.47 minus 4.35, clearly negative, negative 2.88. And these are like percentage points. This is not relative change, this is absolute change. So if you think about, in 1988, if we had 100 pregnant teens in a room, 4.35 of them would result in an abortion. Whereas in 2010, if we had 100 girls in 100 pregnant teens in a room, only 1.47 of them would result in abortions. So when we talk about the negative 0.288, it means 2.88 girls, teen pregnant girls out of 100 less from 88 to 2010 would result in abortion. It's kind of hard to get your mind wrapped around, but hopefully talking about it in terms of, if you have 100 girls in a room, how does that look like, right? 2.88 less of them would result in abortion. All right, so if we look at number 4, we take our new minus old, which is negative 2.88, and divide it by old, which is 4.35. This gives us an answer of negative 0.662, which is negative 66.2%. And this is consistent with the report because the report said it declined 66%. Well, there it is. The decline is negative, and then we have 66%. So All right, let's stop talking about that depressing topic and move on to the next one, which is adult smokers in the U.S. So again, this is another table. We're going to do the first one together, and then I'm going to cut you loose on the next. So we are looking at 1980, and we want to talk about the absolute change. Well, remember, absolute is new minus old. So 1980 would be considered new, and 1970 would be considered old. So I would take 33.2 and subtract 37.4. So my absolute change is negative 4.2. And again, these are like percentage points. You put 100 adults who 100 adults in a room. In 1970, 37.4 of them would smoke. In 1980, 33.2 of them would smoke. So 4.2 less people smoke, or less adults smoke, excuse me. To find our relative change, we would take our negative 4.2 and divide it by old, which is 37.4. And we have a decrease of 11.23%. So same concept in that in the next one, if you went to 1990, now 1990 is new and 1980 is old. So I would like you at this time to go ahead and finish out this table. All right, I've got my absolute and relatives in there. Notice how from 1980 to 1990, we got a big jump here, and 7 less smoked and a 23% decrease. So pretty significant. Again, if you have any questions about this table, shoot me an email and let me know, and I'll get back to you. I would like you now to hit pause, and I would like you to answer questions 5 through 8. 8 is a little bit tricky, but I want you to try it, and then come back and watch the explanation. So hit pause, try 5 through 8. All right. And number 5, what decade was the largest decrease? Well, I've already kind of talked about that a little bit, but 1980 to 1990. And I know it's 80 to 90 because, again, in 90 is where we see it. Well, to get 90, we had to reference 1980, so that's why it's from 80 to 90. Relative change over 10 years for 2010 in a meaningful sentence. All right, well, I'm going to type. So from 2000 to 2010, there was a decrease of 15.35% in the number of adults who smoked in the U.S. Now, your wording could be slightly different, but the things that you have to have: a time period, increase or decrease, what amount, and who are we talking about? Now, it's very important that we are talking about adults, and they are in the U.S., and they smoke, right? You got to have all those details, so make sure we're paying attention to that. Now, in number 7, relative change in the percent of adult smokers between 70 and 10. Well, 2010 is new, 1970 is old. So in 2010, we had 19.3, and in 1970, we had 37.4. So new minus old divided by old gives us an answer of negative 0.484. So you could think of a negative 48% drop from 1970 to 2010, which is very significant in terms of, the amount of adults who smoke has decreased dramatically, for all sorts of reasons. Better education, prices are higher, less places to actually smoke, right? You can't smoke in bars or restaurants or on airplanes or in airports or almost anywhere these days. So I think all of those things together kind of create a less of a smoking atmosphere. And number 8. Now, I like number 8. It's a little bit more difficult, but I want to start with, excuse me, new minus old divided by old gives us our relative change. So when we look at this problem, there has been a 6.2% decrease. Well, that right there with the word decrease, they're talking about a relative change. And the percent of adult smokers in the U.S. since 2010. Well, there's a year. Use this information to estimate the percent of adults in the U.S., adult smokers in the U.S. now. So now would be considered new. 2010 would be old. Well, we know in 2010 that the number of U.S. smokers was 19.3 percentage points, right? So 19.3 out of 100. And now, we'll call it 2015, even though I don't know when this was actually created. We don't know what that is. We're trying to find that. But we know our relative change is a decrease of 6.2%. So remember, percent to a decimal, 2 places, so that's negative 0.062. So when I plug this in my equation, let me change colors for effect, I get new minus old divided by old equals my percent change. So in order to get my new value by itself, I got to get rid of that fraction. So to get rid of the fraction, I'm going to multiply both sides by 19.3. I should have given myself more room for this too. On this side, if you multiply the fraction 19.3 over 1 times x minus 19.3 over 19.3, these 19.3's cancel out, and I'm left with x minus 19.3 equals, when I multiply on that side, I get a negative 1.1966. And then to finish out the problem, I add 19.3 to both sides, and I come up with 18.1034, and that's percentage points. So today, if you put 100 people in a room, approximately 18 of them, adults, approximately 18 of those adults would smoke, compared to 37 of those adults who would smoke in 1970. So a very, very big change between then and now. All right, we are now on page 217. We've got this mortgage interest rate and Indiana Housing Affordability Index. So you can see on this side we've got the mortgage rate, and on the left we have the affordability index. The mortgage rate, I think, is pretty easy to understand in that it is, if you get a mortgage from a bank, this is the percentage rate that you are going to pay for that. The affordability index, which I just kind of figured out this morning, an index value of 100 means that a state's median household income is exactly enough to qualify for a mortgage. Okay, so if, and you might want to read that entire piece down here, but basically that means, so 100 is here, right? We have just enough. Anything over that, so this line that goes up, that is all, meaning we have more than enough to qualify for a home mortgage, which is kind of exciting. And we're going to use this table now to answer some questions. So number 1 is a lot like the number 8 we just completed. The mortgage interest rates hit a high of 18% in 1981. Over the course of the next 32 years, interest rates decreased by 78%. So my relative change is going to be a negative 0.78. What is the interest rate in 2013? Well, 2013 is new. I don't know what that is, but I know in 1981, which is old, is 18%. So when I go into my new minus old, you know what, I'm going to move that over a little bit. New minus old divided by old equals negative 0.78. So now when I go to get rid of the fraction, right, I'm multiplying by 18 over 1, so times 18 over 1. These cancel out. I'm left with x minus 18 equals negative 14.04. Be careful with your negatives. I've seen a lot of people just lose them. They're so easy to lose. We add 18 to both sides, and I have 3.96%. Now, if you looked at that table here in 2013, right, that is pretty close to being 3.96. You can see it, but we mathematically proved it here in number 1. Now, I would like you to hit pause and answer questions 2 through 6 on page 218 dealing with that table. Now, in number 2, you have to estimate, and so you might have estimated a little bit differently than I did, but for the year of 2000, I used 8, and that's old. And then for 2013, I used 4, right, and that is new. So the absolute change, new minus old, I've got negative 4. In my meaningful sentence, interest rates decreased by 4 percentage points from 2000 to 2013. Again, time period, increase or decrease, by how much, and what are we talking about? Ooh, I really should throw the word mortgage interest rates in front of that. I apologize. But notice how I put 4 percentage points, because these are absolute, right? They went from 8% for the mortgage interest rate to a 4%, and that is a 4 percentage point difference. So that's very different than when you're talking about relative change, which we'll do here in number 3. So the relative change, right, so I take 4 minus 8 divided by 8, and I get negative 4 over 8, which is negative 50%. So the mortgage interest rates, your meaningful sentence, your mortgage interest rate, they decreased by 50% from 2000 to 2013. So when you're talking relative change, you actually will use percent because we are given the overall in comparison to the old value, in this case the year 2000, and they did decrease by 50%. In number 4, absolute and relative from 79 to 80. Well, I used 10 for 79 and 18 for 82, and again, you might have used something different, but when I did my absolute, 18 minus 10 is 8, and then my relative, 8 divided by 10, gave me 80%. If you use different numbers, that's fine, right? You had to estimate with the graph, and that is totally okay. The affordability index, from the entire years of that piece, it was always above 100. So that means Indiana has always been able to have an average median income that can afford to buy a house, basically. And in recent years, as the mortgage rates have decreased, we've been able to afford more. So really, I think we can afford more in terms of Indiana people. It's kind of crazy. And relative change in the last 10 years. Well, the last year represented is 2013, and I estimated that to be right around 300. And then if you go 10 years before that, it's 2003, and I estimated that to be right around 200. And again, you might have estimated a little bit differently, but those are the values that I used. So when we find absolute, new, minus old, I've got an absolute change of 100, and then relative, I take my absolute change and divide by old. So I have a 50% increase in the last 10 years of the affordability index. Make sure you read that, because if you use the mortgage rates, your answer is going to be very, very different. All right, page 219. I really like this page. It's my favorite. And it's also the last page of this video. So scenario number 1, times are hard. Everybody at this company has been given a 10% cut in pay with a promise of a 10% increase when profits improve. And we're trying to figure out if that equals out. So in number 1, we're going to estimate how many hours do you work in a year if you work 40 hours a week. Well, 40 hours per week, 52 weeks in a year. You work 2,080 weeks. Excuse me, not weeks, hours. Give me the right words here. Now, I understand that there are vacation days and there are paid holidays, but you still get paid for that, right? So you're getting paid for 2,080 hours. Now, in number 2, you're making $15 an hour. So if I work 2,080 hours and I make $15 per hour, right, my annual salary is $31,200 before the pay cut. So that's kind of what I'm basing everything on. This is what I'm making now. What's going to happen later? Okay, so they do a 10% cut in pay. So if you think about what we did last week, I'm making $15 an hour now. I don't know what I'm going to make after it's cut. So the 100% is what I made now. And if they're going to reduce it, right, they're reducing by 10%. So that's going to be less. So this is not going to become a 90. All right, that's the way we kind of solved problems last week. So when I cross multiply, I get 100x equals 1,350. So when I decide both sides by x, I am now going to make $13.50 per hour. All right, that's my new hourly rate with the pay cut. Okay, well, then they say, okay, profits are better. We're going to give you a 10% increase. Okay, well, let's use that same concept of, okay, I'm now making $13.50 an hour. That's 100% of what I make. I don't know what I'm going to make later, but now I have a pay increase. So now I'm at 110. So when I cross multiply, I am now going to get 100x equals 1,485. So when I divide both sides by 100, I get $14.85. And who sees the problem? I hope you all do. That before the pay cut, I was making $15 an hour, and after the pay cut, I'm only making $14.85. And you may say, well, that's only 15 cents an hour. Well, yeah, but you're working 2,080 hours a year, and you might be at that company for 30 years, right? Those 15 cents an hour add up, and they add up quickly. So when I think about pay annually, well, if I make $14.85 an hour and I work 2,080 hours in a year, I'm going to have $30,888. Well, moving on to this, do they equal? No, because I was making $31,200 before they took away the 10%, and then they took it away and gave it back, and now I'm making $38.88, right? That's a difference of $312 a year. And, if you're there for 30 years, we're talking $9,000. And that can be significant. Not only that, but if they base your raises off of that, you're going to make less in your raises as well. So it's, don't ever let somebody using relative change take away 10% and give 10% back, because it's not going to work. Now, if they want to take away $2 and give you $2 an hour back later, right, absolute change can be added and subtracted, and it works that way, but relative does not. All right, the second scenario. You've been promised a raise of 40% with a new promotion. Good job. Way to go. You worked hard. You deserve it. Okay, so now you have the option of getting the entire raise now or installments over the next 4 quarters, right? Quarters being every 3 months. So which option would you choose? Now, make sure I have room for this one. We're going to talk about option 1 first, which is all at once. And it's hard to just think about this without actually doing the math. So I'm going to pretend that I make $10 an hour right now. Right? That's now. So if I get a 40% increase, okay, well, let's again think about this. I was making $10 an hour. That was 100%. 40% increase would make that 140. So when I cross multiply, I get 100x equals 1,400. So I am now making $14 an hour, right, with my increase, and that starts now, right? That's not bad at all. So now let's go to the next option, so option 2 says you're going to get it over 3 quarters. So the first quarter, right, I'm making $10 an hour, and I'm going to get a 10% increase. So when you figure that out, you are now making $11 an hour. All right, that's the first 3 months. So then the next month, or the next quarter, so that's the first quarter. Second quarter, we're at $11 now, and I get a 10% increase. So now I'm earning $12.10 an hour for the next three months. Then the third quarter, right, because I get 4 of these, so it's 10% each quarter. So now I'm at $12.10 per x 100 over 110. Now I'm making $13.31 per hour. And the fourth quarter, $13.31 over x equals 100 over 110. I am now making $14.64 per hour. So you can see that if you are willing, right, these are 3 months apiece, 3 months for each one of these. So for the first 9 months, you're going to make less than what you could have made if you would have gone straight with the 40%. But in the long run, you're going to make 64 cents an hour more. And let's pretend you're going to be in this job for another 20 years. Well, that 64 cents can really add up. So it might be important for you to think about the long run. And I figured it out that if you were doing $14.64 an hour, well, you're working 2,080 hours in a year, right? That is an extra $1,331.20 per year by going with the second option. So it might have been better for the first 9 months because you were making $14 an hour, but in that fourth quarter starts and you get that last raise, it's going to be worth it because you're going to make more. And and that's starting at $10 an hour. I mean, it'll all work out kind of the same no matter what you use. But don't think, oh, more now is not always the best. Sometimes if you can wait it out, it might be a little bit better. So that is the end of Absolute Relative Change Part 2. If you have questions, let me know. Thanks for watching.